right, so let's talk about trees in depth first search and the in-order, pre-order, and post-order traversal variants. So here we have a tree. It's actually a binary search tree in this case, although it doesn't have to be for this lesson. But yeah, and it's a binary search tree because, as you can see, every node in the tree has a condition where all of the left descendants from that node have a value less than that node. So you can see, and also all the descendants to the right have values greater than that node. So you can see that's the case for all the nodes in the tree here. So let's kind of walk through, first of all, the in-order traversal. So in this case, this is actually going to print out the values of the binary search tree in order, in the sorted order. But let's see how that plays out here. So obviously a recursive function, we'll call it at the root here. And so this pointer is just kind of representing where we're at in the stack. So we'll call it on the root, okay? And so if not root, so if we ever call it, these arrows here pointing to nothing indicate that like the left and the right child in this case are none, so this is a leaf node. But regardless, if we ever end up down here, that is a base case in the recursive function. It is a base case in all three of these, in which case we'll just pop back up to the next, to the calling, the next layer in the stack, in the call stack. So anyways, we'll start here. Obviously the base case is not met, so we'll execute the next line, which is a recursive call in order on the left. So now we're here on the left child, back in this function, like line 2 at this point. Again, not a base case, so we'll keep going and execute line 4 at this level of the call stack. So we'll call in order on left. So here we are again. Now a fresh instance of this function is being run, and again, same thing. So we'll call in order on the left. So now we're here where the root in this case at this level of the stack is none. So now we've hit a base case. Okay, so now we're going to return, right? And so we're going to pop back up here. So at this level of the call stack, basically line 4 has returned now. And so we are on to line 5 at this level. So we'll print the value. Okay, so now we printed 2. Okay, so what do we do next? Now, in this case, we are going to then call recursively into the right. Again, we're going to kick back up now. It's a base case, so we'll kick back up. And so now we're kind of finished with line 6 at this level, and this will just return none in this case at the end of a function. So we'll return to the next level of the call stack here was when we ran line number 4 here at this level. So now line 4 at this level is complete. And so we will now run the print statement. So we'll print 3. Okay. And yeah, I guess technically here there is a none pointer. So let's represent that. So now we're at line 5 here. Now we'll call in order on the right. Obviously that'll kick right back up, and then we'll finish line 6, and then return back up to the next level of the call stack. So we're up here now, and line 4 has completed. So we'll run line 5, print out the value. Okay, and then we'll run line 6. So we'll call Inorder on the right, okay, which will immediately call. So now we're up here at fresh instance of the function, line 2. Obviously, it will then go left here. Okay, then we'll go left again. Okay, then that'll kick back up. And now we'll process this node. Okay. Now, at this node, we'll go to the right. Okay, it'll kick back up. Now, this function on this function for this node is complete. So we'll just simply return back up where we came from. I wonder if it would make more sense to use a line or something like this, maybe. So we start here. Okay, we call left, go left, call left. Okay, then we kick back up, process. Then we over here, that kicks back up. We've already processed it, so then we'll kick back up to here, process 3, go here, come back here, and go back up to 4. We process the 4. Okay, then we now call right on the 4. Okay, now the new node we haven't seen before, so we're going to call left. Right, then we're going to call left. It's going to kick back up, process the 5. We'll call it right here, kick back up. Then we'll kick back up to the 6 now. So now we finished processing the left descendants of 6, and so we will process the 6. Okay, then we'll call, let me actually do that. A little bit nicer. So process the 6. Okay. So we just that. So now we'll go down the right side of 6. Okay, we've never seen this node before, so we're going to go left, kick back up, process the 7. Okay, and then process the right, nothing there, kick back up. Now we're done with 7, kick back up, done with 6, kick back up, done with 4, and we're done. Okay, so that's the Inorder traversal. Okay, let me clean this up. Oops. I have to do this a little bit cleaner next time. Oops. Still learning. This is not a manicured video by any means, obviously. Get rid of that. All right, I'm just going to copy this over here for next time. All right, so now let's look at the preorder. Okay, so let's see, we will again start at the root. For preorder, it's going to first process the 4. Okay. All right, then according to the preorder function, we'll then process the left. Okay. And in preorder, we immediately, or wait, sorry, we don't process the left, we hop to the left. In the preorder, we process the node immediately upon visitation. And so 4, 3. Okay. Then we hop left, right? Yep, process the 2. Okay. Now things are gonna start getting interesting. So we'll hop left again. So according to this, if not root, return. Okay, so then we're gonna hop back up here. Okay, and so we've already printed, we've already processed the 2 node. We just kicked back up from this, and now we're gonna call process or hop to the right, hop to the right. It'll kick back up. Okay. So now we're done with this. And now this function is complete for this node. So we will then hop back up the call stack here. So now we just completed line 12 for node 3. And so we'll execute line 13, which will of course just be hopping right back up. And now we're done with the function for this node. So we'll just return to the caller, which will bring us back up to the root. Okay, so now we're at the root and we've completed line 12. So we'll execute line 13. So we're gonna hop to the right, hop to the right. Okay, so in preorder, process immediately. So that'll be a 6. And then after we're done processing it, we hop left, process. Okay, then we go left. It's gonna kick back up. Go check right. Nope, kicks back up. Then call it, kick up to the caller. We're gonna go right. Go, oh, sorry, that's not right. So okay. So we went left, kick back up, go right, kick back up, kick back up, go right. Now we process immediately upon seeing a new node. Okay. Then we're gonna go left, kick back up, go right, kick back up, kick back up, kick back up, and we're done. So this is the preorder traversal. So 4, 3, 2. 6, 5, 7. Whereas Inorder was kind of climbing up, like 2, 3, 4. Then it searched for the kind of bottom left corner. Then crawls up. Again, Inorder is processing each node after you've finished processing its left children and before processing its right. Preorder is processing a node immediately upon visitation. Then we'll look at postorder here next. Okay, I'm gonna try just deleting that. Get out of here. Okay, so let's see about the postorder. Okay, let's draw it out here. So, of course, start at the 4, and then we're going to process left. So it's first time visiting this node, process its left. Okay, first time visiting this node, process its left. Its left, kick back up. Then we process the right. kick back up. And so now we'll process this node. Okay. So now we're done with this node, so we're gonna kick back up. And now we're gonna process write, kick back up. Now we're gonna process this node. So far, Inorder and Postorder are the same in this case. Anyways, now we're done with this node, kick back up. But then here's where things are gonna change, right? It goes 4. We've only gotten to this point so far. So the next step is to process write before we process the node. So we're gonna process write. Again, first time visiting the node, so we process left, kick back up, process right, kick back up. Now we finally process 5. Okay, now we're done with 5, let's kick back up to 6. Okay, process right, process left, kick back up, process right, kick back up. Process the 7 node. Okay, now we're done with 7. Let's kick back up to 6. So we processed both left and right for 6, so now we're ready to process 6 itself. 6. Then kick back up to 4. And now we process left and right at this level, so we can finally process the node itself. Oops. And then we're done. We're done with 4 at this point, so just gonna return. And so that is Inorder, Postorder, and Preorder. What the hell? How many of them are there? 2, 3, 4, 5, 6, 7.